Okay, so in talking about functions then, some of the ideas here are, the main idea here is we have this function that the function describes a process. And when you have this process, you have some input, you do something to it, and you have the output. So the question is, so what the function description or the function definition, if I say f of x equals 2x minus 4, what this part here tells me, the 2x minus 4, is telling me what the process is. What does function f entail? What does it mean to, if I plug something in and I do this process to it, what comes out? So the question here, for example, what happens if I plug in a 2 to this function f, the capital big F? So if I take a 2 and I f it, what happens? Well, I plug in a 2 into here, so I've got 2 times the 2 that I'm plugging in is 4, minus 4 equals 0, gives me a 0. So what this means is that when I plug in an x of 2, that's a 2, an x of 2, that the f of 2 is 0. If I plug in a negative 3 into function f, if I take a negative 3 and I f it, what happens is I take the negative 3, I multiply it by 2, that's negative 6, minus 4 is negative 10, so that comes out to negative 10. So when I plug in an x of negative 3, the f of negative 3 is what comes out, and that's negative 10. I'm not sure what that noise was, but okay. And just to make the point here, if I plug in an x, and I plug in an x into the same spot here, 2 times x is just 2x. I can't say that any differently. So 2x minus 4, I get out 2x minus 4, which is the definition of what our function was. So there is the process there. Now, as far as showing the relationship, so 21.c is about the relationship between the inputs and the outputs. If I take all of these inputs and I relate them to all of these outputs, this is one way to describe the function. I've told you that this notation here, function f of x equals, and then this part over here tells you what exactly happens. This is a way to describe a function. Another way to describe a function, it's less specific because you don't know exactly how the 2 gets turned into a 0, how the negative 3 gets f'd into a negative 10. But if I draw this over here as a 2, a negative 3, and an x, and if I have this in like an oval shape here, and if I draw a 0, a negative 10, and a 2x minus 4, and I have that be my output oval, what I can say is that when I plug it is use some arrows and say that a 2 gives me a 0, a negative 3 gives me a negative 10, an x gives me a 2x minus 4. And so the main point here is that in order for this to be a function, to fit the definition of a function, is that every input over here, input, must have one and only one output. So for every number, everything that I plug into my function f, once I plug it into function f and f it, whatever comes out, there needs to be something here, as opposed to nothing, and there needs to be only one. I can't. Let's say that function f is 2x minus 4. If I plug in a 2 for the x, I'm going to get a 0. If I plug in a 2 again to the same function, I'm going to get a 0 again. If I plug in a 2 again, I'm going to get a 0 again. If I plug in a 2 and somehow magically I get a 5, then something went wrong. That is not a function. So in the example on page 155, we can have, we've got, the first example here is it has a 4 and a 2, and then a 3 over here, and it has an arrow like this, and an arrow like this. This is okay. This is still a function because plugging in a 4 gives me a 3. If I plug in a 4 again, I still get a 3. If I plug in a 4, I get a 3. That's fine. It's consistent that way. If I plug in a 2, I get a 3. If I plug in a 2 again, I get a 3. That's fine also. This does not tell us what exactly happens between plugging something in and getting something out, but because of with how the arrows are, it shows us that it is consistent and therefore it is a function. As opposed to, on the second example there, if we have an oval with a 4 and a 2 in it, and then another oval with a 3, a 5, and a 6, and if I draw an arrow from the 2 to the 6, and from the 4 to the 5, and another arrow from the 4 to the 3, now I've got a problem. What this is saying is, if I plug in a 2, I get a 6. Plug in a 2, I get a 6. Plug in a 2, I get a 6. Okay, fine. But it says, but because there's 2 arrows here, if I plug in a 4, I could get a 3. If I plug in a 4 again, I might get a 5 this time. Plug in a 4 again, maybe it's a 3, maybe it's a 5, who knows? But we can't rely on that. This is not a function. It might be something else, but this it's called a relation, but it is not a function is the main thing that you need to know. Let's say that there was a 1 down here that had no arrow going for it. Well, the whole idea of a function, the function is the process. What are we doing to this? If I plug in a 1 and nothing happens, well, then that's not very useful either. That is also not a function. It's not even a relation either, but it's not a function is the most important thing to know. And that's that part. Now I can express, let me go back to one that actually talks about a function. Let me just start over this. So let's say, let's go back to the simple one, 4 and 2, and a 3 over here, and with an arrow and an arrow. Another way I can write this with ovals and arrows. I can also write this as a bunch of ordered pairs. Input, in, I caught it, and out. So let's do it this way. I can do it as ordered pairs with my input listed first and my output listed second. And I've got another ordered pair with an input of 2 and an output of 3. So when you're looking at it in this format, what you're looking for is, does an input of 4 have, this tells me that an input of 4 has an output of 3. As long as there's no other ordered pair in my list here that has a 4 first and something other than a 3, then I'm fine. I've got a 4 gives me a 3, okay, a 2 gives me a 3. It's okay for the second numbers to be the same. It's okay to have the same second number with a different first number, different inputs giving us the same output. That's okay. What we can't have is something like, toward the bottom of page 155, if we have, let's see, we've got several ordered pairs here. Green first, 4, 5, 9, 4, 8, and 6. And by the way, since I'm doing it this way to color code it, I'm writing all the first numbers first. The very fact that I wrote 2 4s means that that's you know where you need to pay attention to. So for the second number, let me put the structure in first. So I need to put the corresponding number, which is sometimes called an image, in the second spot here. And so I've got 4, 3, 5, 7, 9, 3, 4, negative 5, 8, 14, and 6, negative 3. You may notice a couple things. If I plug in a 4, I get a 3. If I plug in a 9, I get a 3. That's okay. What's not okay, it can still be a function even if it does that. What's not okay is to plug in a 4 and get a 3, or plug in a 4 and maybe get a negative 5. So this here is okay to have along with this one, but this one here is not okay because it has a different For the same input, it has a different output. Therefore, this series of things is not a function. And that is what you need to know for that. Let's see, example 10, or 21.10, or .9. So .9, A is a function because every number on the left has an arrow pointing to something on the right. B is not a function. Plug in a 7, get a 3 is fine, but plugging in a 5 might give you a 3, might give you a 4. That's what makes B not a function. If we didn't have that arrow and the 4 on B, if it said plug in a 7, get a 3, plug in a 5, get a 3, that would be okay, that would be a function. But we can't have something on the left have two arrows going to two different things on the right. Letter C is not a function because of the M. There is nothing. Plugging in an M doesn't give you anything. Otherwise, if that M wasn't there, then it would be a function. But since there's an M with no arrow in the M in the input oval with no arrow to an output, then it's not a function. Letter D is a function because the arrow just tells you what to do to your input. Kind of a weird way to write that. You'll see that once or twice in the homework. But it's not as common, but that one is a function because it tells you what to do to get it. Example 2.10, letter C is tricky looking, but letter C is fine. It has 4, 3, and 4, 3. That's okay. As long as you plug in a 4 and get a 3 both times, then that's allowable. Even if you plug in a 3 and get a 3, like on that last pair. Letter B is not a function, not okay to plug in a 1 and get a 2, or maybe plug in a 1 and get a 3. That's what makes that one not allowed. And letter D is fine because there are no first numbers that have multiple different second numbers. And so that's how you can tell. So whether it's ovals with arrows or a series of ordered pairs, that's how you can tell whether or not something is a function.